Hello, everyone. Thanks for joining me. We're here today to talk about the importance of powder to metal additive manufacturing. I want to thank 3D PBM for being the sponsor for this event. 3D PBM is a platform which provides media and insight analysis into the additive manufacturing market, which is a very useful service, recognizing that this industry is fast-paced and fast-growing. So again, thanks to them. I'm very excited that we have a very large and diverse sort of group of experts here today to talk about the importance of powder to metal additive manufacturing. We have a group of people that span the spectrum from powder production all the way to powder use. So on the powder production side, I'm happy to have Dr. Martin Conlin from my company, Equispheres. Equispheres has a unique technology for producing powder which is specifically designed for additive manufacturing. And then sort of moving up the supply chain, I'm also very pleased to have Philippe Francoux, who's the general manager of Granutools. Granutools is a manufacturer of high precision, high technology instrumentation for measuring powder characteristics and powder behavior. And then moving up a little further in the supply chain, I'm pleased to have Dr. Matthew Brochu, who's a professor at McGill University. Dr. Brochu does a considerable amount of research into metal additive manufacturing and powder bed fusion in particular. So he does research both on powder, but also in the area of printing parts and mechanical performance. And Dr. Brochu, in addition to being great academically, is also deeply integrated in with the aerospace community here in Canada. And then finally, and I'm very excited to have with us today, Simon Punn, lead metallurgist from Divergent 3D. Divergent 3D is a very exciting company. They're in the automotive space. They've come up with a technology which includes metal additive manufacturing, but goes beyond that. And it's a technology which allows for the production of vehicles at a much lower cost than a traditional factory. And Divergent 3D is actually dog fooding at the moment. They're using their technology to actually produce a car. It's called the Zinger Automobile. And if you haven't seen this car, I'd encourage you to go to the web and look it up. It looks like the Batmobile. It is a very, very cool looking automobile. And finally, of course, myself, I'm with Equispheres. I'm the Vice President of Strategic Partners and Alliances, and very pleased to be hosting this event. Okay, so the first question I'd like to ask today, I'm going to sort of present to the group as a whole, which is metal additive manufacturing holds a lot of promise for lighter weight production, bespoke design, improved supply chain, but it still hasn't completely taken hold in the industry. It's still used mostly for prototyping and R&D, and hasn't disrupted the $13 trillion a year manufacturing industry. And I was wondering if the group could sort of give me their thoughts about what they think the obstacles are that are preventing metal additive manufacturing from going full mainstream.
I guess from my perspective, the main barrier to adoption is just the cost associated with the technology, which is mainly linked to the speed of production. There's also somewhat limited materials available, and generally speaking, the reliability of the printed parts tends to be rather variable, which impacts the mechanical design. So those are kind of the three that would come to mind for me.
Yeah, and I want to piggyback off of Martin's comment there on the material selection. I think this panel and many of the users like Divergent knows well that there's only a very selective few materials that can be printed. Specifically, if we talk about laser bed powder fusion and aluminum, right? There's only a handful with the famous ALSI 10mg that was developed from a well-wired composition. From a user's perspective, that really limits what we can do and provide in terms of application. So one challenge that we see is the trend or the needed trend to develop new materials that are specifically designed for 3D printing and in an application-driven manner as well.
On my side, what I will add is the reliability. This is actually one of the things that I believe strongly. How can we increase the reliability, reproducibility of the part that we're actually fabricating? So this is, to me, a big issue to actually reassure all the final user of those AM parts that the part will actually sustain both the life and performance that they're looking into. So this is a big thing that we have to actually solve. How we can increase any aspect that actually can improve the reliability of parts is critical.
If I may add up on what Dr. Brochu is saying, I think if I consider the main industries at the moment, which are aerospace and implants, medical implants, for example, they are both strongly regulated industries. And in order actually to increase the mass production in those two, I think we have to be able to speak a common language, and we have to be able to progress in terms of standardization. And there are a lot of efforts which are currently developed in those areas, but that it takes time. It takes time to develop a common language, a common understanding, so that it can be spoken throughout the whole supply chain. And it's something that we are putting a lot of effort in. Granule Tools and many other companies are currently meeting a couple of times a day so that we can progress, move faster, develop a common language, develop the same standards, so that we can integrate those into aerospace and medical implants industries, and then move forwards into volume production.
Thank you. Those are interesting perspectives. I'd like to ask a question directly to Simon, because Simon is in fact our sort of user here in the group today. There's an adage in business that you can have it good, fast, or cheap, but you can only pick two. And I was kind of wondering if you could sort of tell us what the priorities are at Divergent 3D with regard to what's most important to them and to your organization, and also, how that sort of relates to feedstock. What exactly are you looking for feedstock? What kind of issues are you having with feedstock? What are your thoughts on that?
Thanks for the question. And being a tech startup company focused heavily in automotive, I'd say productivity is a hurdle that we're trying to get over when competing with conventional manufacturing techniques like forging, casting. So productivity has always been this key milestone that we're trying to reach and to compete with these other techniques. So right now we're with powder stock. I believe the industry standard is the two cuts, 14 micron, so 15 micron to 45 micron PSD, D10 and D90. And then there's the 23, 25 micron to 70 micron. But as we see, right, like, so the maximum layer that you can have is 73 micron. So, if we want to increase productivity, we would have to shift and have standards and specification to shift that up to a coarser cut. And at the same time, we need the powder feedstock to pack well, so that we get that repeatability that Dr. Brochu has mentioned. So that's a big challenge, and that's where we're trying to work with our vendors, powder vendors, to develop in our machines. Before the panel, I share that we currently have a strategic partnership with SLM Solutions, and that we're basically taking feedback like this back to the machine manufacturer and to say, hey, how can we print coarser powder and increase the productivity? Yeah, does that answer your question, Doug?
Yeah, it does. And I'd like to explore this a little bit more, certainly in the automotive sector, as the sector you're in, Simon, cost is very important. But we're seeing this also in things like the aerospace industry. And of course, cost of production, a lot of the printer manufacturers have been adding more lasers to their system to get the cost of production down. I think recently we've heard they're up to 12. And certainly, as you describe, Simon, thicker powder layers are a good way to increase production speed. But I'd like to ask the group, what more can the powder do? What other features and characteristics of the powder are possible that could help with the speed of production?
I think what Simon mentioned is the primary one, which is just increasing the build speed by increasing layer thickness. But in order to do that, you have to have a nice spread density in the layers so you don't end up with porosity in the final part and affect the mechanical properties. So that's a big lever to pull there.
Yeah, and aligning with what Martin just mentioned, I do believe the spread density, and the spread density is going to go as well with the spreading speed. How can you do this optimization? You also have to take into consideration that within the spread density, you need to minimize the fluctuation of the laser interaction with the powder bed. So that's quite important as well. And then in terms of reproducibility for your mechanical properties, you have all the factors that comes into play with the surface chemistry, the moisture pickup, all of those aspects that are often neglected in terms of like a handling characteristic that needs to be taken into account. And if you can control all of this, you minimize all of those detrimental effects of moisture pickup, you're going to maximize the chance of obtaining high mechanical performance parts.
So Philippe, Dr. Brochu had mentioned some characteristics of the powder that he considered to be important, such as spread density, moisture pickup. What can you tell us about the class of tools that you've seen, that you've developed, that you've seen that are helpful in identifying these properties? And what can you tell me about them in terms of their ability to be sort of useful in a production environment?
Okay, thank you very much, Doug, for the question. Just to mention that the way we ended up working in additive manufacturing is a little bit by accident. Actually, we published a paper focused on the spreadability, an academic paper, and we actually found out that what really drives the spreadability or the not ability to spread is the coupling between the cohesive index, the cohesion between inside the powder and the printer and the recorder of the printer. And so that was the first requirement was the ability to spread equally. So it is very important for the powder that this powder can be actually spread across a layer where it is flat and homogeneous. So that was the first requirement. The second requirement, and this is still under discussion, is the property related to the packing. Okay, so we were somebody was mentioning whether the feedstock is able to pack well. We talked about repeatability, and we talked also about how fast it can pack. My current understanding is that the main, for most application, the repeatability is most stringent. So the problem is when you have layer after layer and you have difference in the packing of those layers, that will induce non-homogeneity inside the build and inside your parts. So it's more about the repeatability than about the speed of the packing. Then the third one, which we are working a lot on, is the electrostatic properties. And those electrostatic properties are very often overlooked, but they are very important for two reasons. First, because electrostatics can play a role in the cohesiveness of the powder and therefore in the spreadability. But more importantly, if the powder gets charged and it can charge, the charge can build up. The powders can actually stick to the walls, stick everywhere, create clogging, and so on. So from a holistic approach, I would say spreadability is very important. The packing, but not necessarily the speed of the packing, but more the repeatability across the build. And the last one is electrostatics.
Thank you. So Dr. Conlin, both Philippe and Dr. Brochu have sort of identified some key features that they believe quite firmly are important for metal additive manufacturing. As a company that's producing powder for the industry and producing powder which is specific for metal AM, do you sort of agree with their assessment? And what is your organization doing to sort of provide powder that has these kind of features and characteristics?
Yeah, I do agree with them. I think that they've hit on many of the important properties in the actual application, and those properties or that behavior is derived from the attributes of the powder. That's why we strive to make powder that's highly spherical with a narrow particle size distribution, an absence of fine particles that are prone to that electrostatic charging that Philippe mentioned, and a smooth surface so that they absorb minimal moisture, and that if you bake them, they desorb very well. So that's our focus.
Good, thank you. Simon, I sort of want to bring it back to you and just sort of talk maybe a little bit more generally about the industry. Simon, I know your operation at Divergent, you've got close to a dozen printers. I know you have a relationship with SLM, which you've mentioned. What would you say to the industry as a whole, not just to SLM, but to the industry as a whole, the printer industry as a whole, what they could do to improve quality, improve production speed, which we've been hearing about, improve powder handling? Are there any comments you have about those issues?
Yeah, Doug, I'd say you hit on the entire portfolio of areas where they can be improved. But something that's closest to me as a materials engineering leader, Divergent is, again, I have to bring back to the productivity problem. And I know we have a lot of experts with powder here. As we increase the print speed by manipulating the process parameters, we see a lot of defects that could be mitigated if the powder quality is better than by that I mean they're spherical, they don't have satellites, and it can be well packed. So all those things contribute to the lessening of the charging, right, of the powder, so then they become less sticky and they can actually spread well and get homogeneous parts and microstructure. So I would say that there's definitely going to room for improvement in the powder quality. I think you also mentioned post-processing right now, and I think I witnessed this in aerospace. You have a team of post-processing technicians where they are manually removing support structures and other features that won't go on the actual part. So if post-processing can be automated or semi-automated, and I think that is the trend of the industry. Right? We talk about Industry 4.0 and digital twin. I think this vision of automating post-processing fits well into a digital factory.
Okay, thank you. Thank you, and I'll put this to the group, although maybe not to Dr. Conlin, but if you folks had to give advice to powder producers about what they should focus on to improve the quality, to address some of these issues that have been raised, what advice would you give them?
can I start?
You sure can.
So I mentioned the limitation of using these off-the-shelf commercial alloys that are 3D printable. My advice for any powder maker would be open to taking new chemistry, investing in groups like Dr. Brochu's effort to make a couple of new batches of powder where you can put in the printer and try and see you get better properties than what's commercially available. And I think that is key to unlock many applications, at least for the automotive industry.
So if I may add on this as a, I don't want to call it an advice, but a suggestion. I really like the concept of trying to understand what are the powder characteristics, what are the limitations, and what are the advantage of all of the powders that people are actually applying. To fully grasp what is the variability and to sort of like foresee what will be the issue that they might face when it's going to be time to print. So sadly, I have a feeling that too many people are believing that all the powder behave the same, which is not really true. And all of those minor difference sometimes can be healed by the process, but sometimes cannot. So I firmly believe that this aspect needs to be thoroughly understood. How do we ensure that there's a good compatibility between the powder and the process?
Great. Great. We've been talking an awful lot about, well, powder bed fusion almost exclusively. Certainly there's a lot of interest in, and we talked about production and speed of production. There's a lot of interest in binder jet technology because it has the promise to produce parts 100 times faster and at a cost which is comparable to casting. What role, well, a couple of things. I'll just start with this. What role does everyone feel that binder jet will have within additive manufacturing? Will it dominate? Will it have a role to play along with powder bed fusion? What's sort of the thinking there?
You want to go, Simon?
You go ahead.
I'll go first. So from the academic perspective, if I'm allowed to go first, binder jet is a sintering-based process. So now it's a total different ball game in terms of what is the cohesion between each of those particles together. So now the surface chemistry, possible contamination with the binder during process will play a key role into the process. And there's still a lot of aspect of binder jetting that needs to be studied. Are we going full solid state sintering, a slight subsolvus sintering? There's many aspects that needs to be studied on that front to fully grasp the potential of this technology. So yes, for mass production, I think for mass production of potentially lower cost application, binder jet has its place, has a good potential to be there. But there's still, as I mentioned, we're still having the same hurdle. What will be the reliability, repeatability of the process. And all of this now comes down to the sinterability and powder properties.
Yeah, absolutely. And coming from the automotive industry perspective, automotive, unlike aerospace, very cost sensitive. Even with raw material, as opposed to aerospace, the buy to fly ratio is more important. So we look closely at feedstock, and this is something I learned from working with the procurement team and several vendors, is how can we maximize the usage of the yield. And when we talk about traditional gas atomization technique, binder jet, we know utilizes a cut, a PSD similar to MIM. So, what we're trying to do is to see if we can utilize the entire yield by allocating the MIM grade yield of the atomized lot. For BinaJet, we already said that middle, right, for SLM or DMLS, and then the coarser cut maybe for DED or E-beam. So from the automotive perspective, we think that there is a future for BinaJet because we can utilize the yield with this technology.
Yeah, that's sorry. Go ahead, Philippe.
So when it comes to powder properties, binder jetting most important property is really the packing of the powder, because if the build is too tight, then the binder is not able to really go through the whole layer of powder. Now, if it's not tight enough, obviously the density won't be there, and the parts won't be meeting the requirements in terms of density. So packing is even more important. So it has to be very well controlled. On the other hand, just from, I've been working a lot with binder jetting customers. There is a huge future for this technology, because basically all the MIM customers, all the metal injection molding, all the casting customers, they can reuse parts of the plant. They can actually divert their process of the parts and use binder jetting, and then put all the parts back into the oven and then sinter them. So there is huge productivity that can be done there.
Great, thank you. Sort of last question then, I think, for the evening, because I know Philippe, it's getting late in Belgium. Just in general, for the group, what are your predictions for metal additive manufacturing over the next 12 months? Are you expect to see greater adoption? Are you hopeful to see some of these new alloys that Simon is hopeful to be able to utilize? Where do you see the industry going?
I think I read somewhere, it was probably an Ernst & Young report from late 2019 that already 18% of end users have already adopted metal additive manufacturing in the production line. So that's across, I think, the entire manufacturing platform. But specific for automotive, in the past few years, we've seen a lot of buy-in in the CTO or the upper or the C-suite folks having tremendous interest in investing in metal AM for the production line. So I believe that it's going to continue to grow, especially if we can unlock many other applications than what's being done now with new chemistry. I would imagine the growth to be tenfold. Oh, but you said the next 12 months, so 5 times.
There you are. Bold prediction.
I would not like to go and bet on a number, but I do believe that, as Simon just mentioned, we're going to piggyback on the hard work that the industry have done over the last couple of years. Now we have, in terms of powder bed, we have quad lasers that start to bring a positive economic balance to the production of parts. There's still some issue that needs to be solved with this, but I do believe that this is going to grow more this year. And the other point I think Simon touched that was really important is the buy-in. And we have more and more buy-in by the people because, again, backing on our work that was done in the previous years. People are starting to believe more and more in the properties, reliability, and so on parts. So there's going to be a growth as well on this front coming from the buy-in of the people, buy-in of as well the authorities that will actually push more and more restriction or more severe condition for whichever good we're working with. And at this time, I think AM will be able to fully capture on this opportunity, to be able to deliver those complex parts that will be able to serve those more stringent applications.
So my 2 cents in the last, I would say in 2019, last year, at the end of the year, we were seeing people, they had been buying a lot of, they had been buying a lot of powder bed fusion instruments, and they were basically getting money to buy 2 or 3 of the systems and to try that out. And then you saw a strong push from their managers to say, okay, now let's buy more powders and let's get this process under control and let's make parts. And there was a huge push for that at the end of last year. So what we saw at the beginning of this year is that binder jetting was picking up, but still there was a strong push from the managers to get parts produced and to get these parts used into their products and the products sold. And I think this is still the case today. So what we see now is that people get problem with the process. They have to fix those problems. They have to buy more powders and they have to produce more parts. And that is what everybody is expecting. It's really the proof of the pudding. And this is happening now, and I think it's going to happen for the next 12 months.
Yeah, no, those are good insights. I noticed that nobody has taken a concern about COVID-19 and I know certainly, Simon, you're in the automotive industry, but certainly COVID-19 has impacted the aerospace industry. I know, Dr. Brochu, you're deeply integrated with that community. What's the prognosis there, in your opinion?
With the aerospace industry, I mean, the manufacturing will restart when we can say COVID will disappear. If, quote, we can say it's going to disappear. But there's a side tangent to this, Doug, that I would like to just mention is COVID was actually a real reality check to actually show how AM could spin on a dime and start producing part that the conventional manufacturing industry could not. And to really, if you go back to the month of February, March, April, the first big period of COVID, the thing that you were hearing is like AM helped to develop this, AM helped to develop that. And there was a lot of exposure happened with this. So I think, yes, it impacted very badly many industries, but the EM field keep progressing, and it made really thorough progress during that period too. And when the economy is going to pick up, and if we're coming back to normal, I mean, we're going to take advantage of all those developments that were done during the COVID period. So, yeah.
Good.
Yeah, and I like to add to that. I've heard that automotive industry isn't impacted as much as the aerospace, but for us, being a startup, late stage startup tech company, we've actually picked up a lot of interest from external customers, new customers, and investors. One point of feedback that we got was, well, in Europe, one of our customers, basically their lines have to be stopped, right, for regulation reasons and whatnot. In the digital manufacturing platform that Divergent has, right, you can put minimal people and heads on the production line and still be able to get the same parts out and meet the time zone. So if anything, the COVID case actually helped us show and demonstrate to our customers and investors that the new trend is using the digital manufacturing platform.
No, that's fascinating. Those are very good anecdotes about the flexibility of additive manufacturing, which has been promoted as one of the key benefits. And yeah, clearly, COVID has been disruptive, and it's good to hear that it's helped people adapt. listen, I want to thank everybody for participating here tonight. I found this very useful, and I appreciate you joining me. Again, my gratitude. Thank you all for the wonderful discussion.
Thank you for the invitation.
Thank you.
Thanks a lot, Doug. Appreciate it.
Thanks.
Bye-bye.